start out, 3D printing has made its way back in the news in a good way. Like many technologies, it goes through the hype cycle of it's going to change the world and then kind of disappears into all the reasons it's not to succeed. And now all of a sudden, because of the COVID crisis and people's kind of easy response to it and being able to prototype things quickly, it's back in the news. I guess the question for you guys is this a turning point? Is this, or is it another flash in the pan and we'll be back to the negative news cycle soon? And just curious what you've seen in terms of using 3D printing for the response, and does it have any ultimate outcome on the success of the industry? Maybe Dan, you want to start?
Sure. You know what? I'd love to. You know what? That's a really great question, Carl. My gut instinct is to say I don't think it's a watershed moment. No, I mean I think that we have a lot of opportunities right this second, but I think that if you're not really plugged into the whole wider industry, you're missing out on the fact that classical manufacturers are executing a build out at rapid pace that is amazing to behold. I mean, I have some friends that do this PPE stuff the old-fashioned way, let's say, and they're talking about reaching millions of units by the end of this month. And so I think that we have a very defined window of opportunity here, but I think it's a window.
Hey, Martin, nice to see you.
Yeah, that's so many, sharing so much time at Autodesk. Really great.
Yes, Martin and I worked together for a very long time. Hey, Martin, any difference in opinion?
So I would not say that this is a turning point, but I would also not say that this is a flash in the pan. I think it's a wake-up call and showing the advantages of additive manufacturing in terms of being flexible, like here in Germany, masks were going out and then community was coming together and doing all, we also participated in providing some of our machines to print respirators and other things. Yeah. So it is showing that additive manufacturing can react very fast, flexible. It is distributed manufacturing, and also certain things in terms of fast time to market, and not only for some prototypes, but already for things which are working quite fast. Yeah. So it is giving us the opportunity to bring additive manufacturing again on the line, and also showing that this is not only short. Yeah. This is longer term, that we can leverage where we are already standing with our technology.
Yeah, no, it was interesting. I've been spending the last 3 or 4 weeks making PPE in my shop. We have this whole distributed manufacturing. And while some of the very early prototypes and some of the things we've done have used 3D printing, we eventually landed on this design that's a combination of a baseball hat and a piece of plastic. And it was, we essentially came up with this design because we had to make tens of thousands of them. And we couldn't see any way to 3D print them quickly enough.
We actually used one of our current development, which is the laser profusion. So where we are using millions of diodes to do door openers. And some of my colleagues were going around here in Munich and in the rest of Germany and providing these, especially in elderly homes, these door openers so that they don't need to touch the handle. And it is really amazing how this new technology, where you can print one of these pieces within 10 seconds. So we are also getting now technology with powder bed fusion, and where we had today certain times of limitation, that we can show that we are coming in the time or in the amount of cycle times which the normal production is requesting.
Yeah. So, I mean, that kind of leads into this question of, as we look to reopen the economy, and I know this is a hotly debated topic in the US of how quickly we should do it. One of the things I found in my business career is that lots of companies know how to cut during downturns and crises. But the best companies, while they act conservatively in terms of maintaining their cash position and everything else, they also take the opportunity to retool and come out doing things where hopefully they're more focused, they're more prioritized, they have better priorities, and they choose to do something they may not have done before. You know, in other words, they use the crisis as a reset.
Yeah.
And so I'm just curious what you and your companies are doing, and maybe we can start with Ryan.
So I think you know, I'll talk about what HP is doing, but I also want to relate that question back to the original question, because I do agree with Dan and Martin, but I'm a little bit more bullish on what this opportunity can mean for the industry, simply because, you know, to Dan's point, you do have this huge engine of traditional manufacturing that will need to kick in at some point. I mean, it makes too much sense for these reactive opportunities to stick with additive manufacturing, but also a little bit to Martin's point, being able to fill that gap in response to a disruption is what we're seeing to really take advantage of those opportunities. But going forward, I see no reason why that can't become more and more the norm for product development, where you release an initial version of the product, could be manufactured exclusively on additive, and then if it's successful, then you make those investments and kick forward. And so I think HP, in response to this crisis, obviously we're doing a lot of things in the core business to make sure that our offerings are in line with the way people work. As you can imagine, though, our PC and our core print businesses are not being disrupted as much as other industries are, simply because the demand now to turn everybody's living room or den or spare bedroom into a home office is a positive, you know, positive impact as far as HP's product lines go. But I do think we're also looking at what do these trends mean in the future going forward. So how do we better incorporate products and offerings that really recognize that things aren't going to go back completely to normal, right? We're going to, you know, we're making these drastic changes, and when this is all over, there will be a shift back towards what we would consider normal, but it won't go all the way back. And so really, how can we use this to inform our product offerings to take advantage of what this new normal will be? Same thing with our 3D printing and digital manufacturing businesses as well. We're really looking to say, how can this opportunity and what emerges out of COVID better inform what we bring to market in the coming months and years, just like we talked about, or what I talked about yesterday.
That makes sense. First, welcome, Meta.
Hey, Cal.
Okay, so is that a virtual background or a real background? Because it's
a virtual background.
It's the coolest background, but you're the only one who is industry appropriate. But anyhow, I figured you were you weren't in the factory. So do you have any thoughts to share on what you think's happening, how you're going to respond to this, what it means for both your company and your customers?
Yeah, hey, Carl. So I want to go back also to the first question that you asked. Yeah. I think, speaking of from an S&M perspective, pre-COVID for us is still a growth region, right? So additive, although a lot of hype that disappeared, that happened early on, the industry was still growing. Maybe not to the level that everyone expected it, but it was still growing. But if you really looked at the industry that we were talking to, the adoption was coming quite strong in the next few years, regardless of this COVID. Now, what COVID has done is just highlighted how important this industry is and how it's the future. We saw a lot of challenges with supply chains out of China in early January, going into February, and people start talking about it, but it hits really hard when it came to the US, and everyone started really highlighting, you know, the importance of this. Then you step back and you say, did it help at all? Did it do anything different? Then you look at least for us, you know, we saw some of our customers came in and they did like mold injection and stuff like that. Within 48 hours, they start printing stuff. And it's just like, you can't do that with the previous industry. So I think that what you see in the news, I hope it's not a hype or is going to create a hype. We don't want that. What we want is, you know, awareness and how important this technology is. And it's the future, whether it's, you know, how you're going to do it today or later or tomorrow. That depends on each company, how their vision and how much they want to invest in the future. Now, COVID came in, this stuff happened. Now, what do we see? Well, we see a lot of slowdown in terms of uncertainty, in terms of CapEx and things like that. So we see a lot of, a lot of investments that are being pushed back just because everyone is back at home and there's not a lot of activity happening. But the dialogue behind the scene is very strong. This is the industry that's gonna change it. For us, we continue to invest. We're not stopping. So we are cautious about our financial positions. Our investors are still very strong believers in the company. We do have the technology that I think will emerge much stronger than when we entered the COVID period.
Got it. So, one of the things that I've seen is, as you said, even before the COVID crisis, there was a small trend towards moving manufacturing back onshore. Digital manufacturing in general was allowing people to do the same kind of work in higher labor cost areas. And I'm wondering if anyone thinks, both with additive manufacturing, but even traditional forms of manufacturing that are now, computerized, are we going to see more of this moving onshore? I mean, I think everybody has been kind of dismayed by the broken supply chains and, how robust they are in good times, but how brittle it is, and when things break, and particularly during crisis, no one's willing to do it. And so do you think, this is going to kind of accelerate that move to certainly have national strategic efforts to make sure that some of the critical things are manufactured in each of the countries? I'll let anyone want to jump in, go right ahead.
I'll just quickly say that I do think that with the work that HP is doing with governments in the US and Europe, there's a strong demand to protect supply chains of these critical components. So I think that that's going to be one force that does push for some capacity to return onshore. As we've seen with swabs and testing and critical components, you can't get them. There's no company that makes them here. And I think that everybody's recognizing that's a big gap. Additionally, you look at new opportunities. So, we really look at Smile Direct and their utilization of 3D printing as a forward-looking opportunity for how manufacturing may look in the future. With, I'm big on the value proposition of customization and personalization as a result of additive. And so I don't see how you can have a, foreign global supply chain when every one of your products needs to be personalized to a customer. So you see additional trends pushing manufacturing to more localized and more onshore efforts. So I think those are the two factors that may come together to both, continue that trend going forward.
Do others see the same thing?
Well, I was going to say, to jump in, I think the other aspect of this that's important to consider is the human aspect of it, right? So many people have been furloughed or lost their jobs, right? The unemployment numbers have dramatically spiked and gone up. And if we are going to go, push for more manufacturing onshore, those people had to come from somewhere, right? That's not going to happen if we have a 3 or 4% unemployment rate. And so from an opportunity standpoint, right, I think that could potentially serve as a catalyst for a reset, right? People may choose different jobs when they come back. People may, want to get trained in different things when they come back. I think it's also important because it's going to honestly shed a light on just how potentially inefficient some of our education is, right? Because if it takes a long time to learn the software, right, all the folks who lost their jobs are the technicians, right, and they have to come back, how much time does it take to kind of move forward, right? So I think it's going to be also an opportunity for all these companies to figure out where they're inefficient in their hiring processes and their training processes.
Yeah, I want to echo that in terms of that the biggest opportunity is definitely around that COVID brought digitalization with a steeper learning curve. Yeah? And we are seeing that in our own company by using MS Teams and other things, working with 90% of the people in the home office now. Yeah? Without COVID, I would think that this would have taken way longer that people are accepting it. Yeah? And the same thing, what we are seeing is that customers are accepting more to use remote services and things that we can go on the systems to help them to keep the machine running. And we were seeing that particular with the polymer systems, yeah, because these systems were highly in demand to print something. And like you were just saying, Harshil, in terms of also that we have big demand or getting demand in terms of that people want to learn because they have now time to learn. And the other thing is also reaching partners and customers in terms of getting ready after we going back to normality in terms of how are we introducing things like distributed manufacturing. And like Ryan was saying, yes, certain things will go back to normality. Yeah? But I think COVID will bring us a big push in digitalization and acceptance, yeah? Especially in Europe and also in Germany, where we are very, very conservative and taking care about data protection and other things. But it shows you have to give up certain things, yeah, to connect, to live, and other things. So that's for me a big opportunity. But as what you were asking in terms of challenges, what we are definitely seeing is currently really the supply chain, and especially keeping the interest up in already projects which are running and which are short before invest, because these crises have always this kind of uncertainty, and then mankind try to save their wheat and other things instead of investing. So it's up to us in Salesforce, yeah, to show which opportunities we have. And the good thing is really I believe a big believer since long time in distributed manufacturing, and something which I inherited and bring from Autodesk all the knowledge into EOS, yeah, having a good foundation in terms of software and openness and with APIs, so that people can hook up and integrate the systems. And I like that's also what we will discuss later, is one of the things how we can grow business. Yeah.
Yeah. So let me just shift the conversation a little bit to, like I said, I think the best companies do things differently as a result of a crisis. They don't just hunker down and try to do the same things with less. So I'm just curious, maybe we can just go around to everyone and say, what are you doing differently as a result of this? And so how are you thinking? How are you thinking differently? How are you breaking the rules? What are you going to do to differentiate yourself from your competitors going forward? You know, the expression is, you know, never let a good crisis go to waste. So we've had it. Expectations of customers, expectations of employees have changed considerably. So the question is, what are each of you going to do differently as a result of this? And so maybe we'll just we just go around and.
I can start. Look.
Okay, great. Thank you.
I think this is definitely a moment that we all got caught into, and we start looking what do we do differently in this environment. And the team, at least in SLM, we start talking to customers, different customers, not even our existing customers. We just, how do we play a role in helping and addressing the problems that we see in this coronavirus era? So we start looking at and creating alliances in terms of collaboration and addressing of the challenges that the industry sees. How do we go and to institutions, to governments, to small businesses, and connect them all together in terms of, you know, here are the things that we can do, and here's how we play parts. Here's how we support you. And we connected these networks, and we start playing a big role in terms of delivering solutions that to the problems that they were facing, whether that's through spare parts, whether that's through collaboration, whether that's sharing IP. These are things that didn't happen before. So I think this is a very, very important thing that happened, for at least for me and my team. We would have never thought to do this if you asked me end of December. So that's really opened up, I think, a collaboration aspect that it didn't exist before. And I think, you know, we are even open to, you know, when we talk about competitors, we're in the same technology field. We're looking at how do we push this technology beyond from what it is today? How do we make it mainstream and really make it really the norm versus the exception and specialty items? And the only way you do that is you break these barriers in terms of the adoption, and having people understand the technology better, understand its capabilities. And this is really, really where we see, our opportunity to play a bigger role and help the industry move forward.
Ryan, you want to talk?
Yeah, so I can follow on with that because it's a similar approach. So speaking with customers at an increased rate has been one of the tenets of how we're going to come out of this in the best possible position. Focusing on, though, not necessarily what can MJF do to solve their problems or what can HP do to solve their problems, but what can we bring to the table to make sure that we're integrated with all the problems that they need solving? How can we make sure that we're approaching all of the things that they want to do as a result of their COVID disruption in a way that's complementary and cooperative with the other solutions that they need to stitch together for their particular business? Coupled with that is renewed focuses on government engagements, because we do feel that policies are going to shift as a result of this, and that we want to make sure that we're able to take advantage of integration of additive and digital manufacturing in this shift of policy. Some of the things around, time to approval for FDA use cases in medical is really driving a lot of that as well. And then also potentially making sure that governments understand the value of keeping amount of flexible, high quality production onshore, and making sure that there's standards and potentially even government funding to support those types of initiatives as a really national imperative for governments around the world. And then also education is an area where we're gonna spend more time and focus on understanding that this is a real learning moment for how you can better incorporate and take advantage of additive, and that needs to start in the universities as well. So I think those are the areas where we're really focusing on a high degree of feedback, high velocity feedback loops in these areas to make sure that we're coming out.
It's good, Dan.
Yeah, and to piggyback on a little bit of that, another area where we're really trying to strike out is, in the whole area of standards, ASTM standards, SAE standards, MPI, and trying to get all of our processes so that when manufacturers do decide to make this leap and bring us inside, they have something to go by, right? Like we can at least say exactly how this equipment and these machines are going to perform once they get to their facility. That doesn't answer the question of can we make every part in every geometry and do we win every battle? It doesn't answer that, but it would at least give these manufacturers and these parts makers like a little bit more confidence in this big investment. And if I could just real quick add a comment about the onshoring, reshoring. In philosophical circles for years, we've been hearing about the oncoming gig economy and resilient communities. And I think that maybe what we're seeing in this COVID is maybe a little bit stronger of a push to the idea of the resilient community than may have happened on its own. There's still a lot of problems to solve there, but I think that could be one thing. And in terms of what companies are going to do differently, I don't know exactly what X1's going to do, but there are some questions I ask myself. Everybody, and I'm sure we're all in the same boat. We're all working from home. We're all trying to network with our colleagues as much as we can. But by the same token, my accounting department hasn't been here for 4 weeks. Why would I ever have them back? And I'm not being smart, right? Like that's not a joke. Like it's a question of, okay, if I am square foot real estate short, why aren't I sending more people home? Why would I tie up 1,000 square feet of space for human bodies when I don't need to? Why pay for their lights? Why pay for their water? Why pay for their coffee? I'm really interested to see how that is going to evolve. And I could definitely see, we're talking about augmenting our own personal skill sets and learning something new. I could certainly see this as being a big break open for the gig economy, those task type services that you sign up for and somebody assigns you something to go do for them and then you go do it. I could certainly see that kind of an economy expanding.
Yep. And Martin, anything about what you're doing differently?
What are we doing differently? Yeah, it's in terms of, so one of the things again is helping us is to accept new methodologies, yeah, to faster develop MVPs. And as EOS is now 30 years old, yeah, and it has a certain reputation in terms of, and it was like at the beginning in Autodesk, yeah, everything's invented here and our engineers want to protect everything. And bringing this in knows that we have to, and that is where I'm breaking rules, internal rules, yeah, in terms of having more open API. What is our core IP? What is open? How can I build up a community and building the last mile? Like you know, AutoCAD didn't know what a screw is or what a house is or whatever. That was done by the application developers on top of it, yeah, and they were going the last mile. And I think that is where we, as an industry, need to give up and building a community which is helping us to do the last mile. Yeah? And I think we are also coming to that. What is missing for us, that customers can faster adapt our systems and going into serial production, is in a certain way standardization. And the other thing is, a lot of our customers, common customers, it's not only ours at AOS, I think it is for all my colleagues here, they are focusing too much to understand the process and certifying the process instead of understanding, I want to produce a part and I'm telling which methodology I'm using. Yes, I want a powder bed fusion system, yeah, and I want to use it with a laser or with something else, but then I'm determining what are the material properties and I'm testing against it, or the test is done during the build. Yeah? Yeah. So that is in terms of also what you were asking, what are we doing differently? It's in that area also trying new business models and sharing risk. Yeah? And that is with things like pay-per-use. Instead of asking for a lot of upfront investment, yeah, going to these things that we are saying, we are believing in our systems. Yeah, we are believing in our systems. We think they will produce and we can offer to you a pay-per-use model. Yeah, it's not yet quality per use. I think there we still need to be way closer to what the application is, but definitely taking this risk to try out pay-per-use, like my fellow colleagues here are also doing. And this is, and that is my last thing in terms of that thing. We should not compete amongst ourselves. Our main competitor, like we were saying at the beginning, is subtractive manufacturing. They are bringing everybody together to fight us because they have fear in front of AM. Yeah. And when you are looking, and that is, yeah, the total manufacturing market is, when I have it right in mind, $35 trillion US. And additive manufacturing is around 20 billion. So it is a 0.004% of this whole market. We all should stick together and thinking how we can share our pie together in making it bigger. And there is this funny picture, which is a cartoon of two donkeys, which are tied together with this rope, and both are running to a haystack on the opposite side. And a big haystack, instead of both donkeys going first to one haystack and eating it together and then going together to the other. And I think there, we as an industry should join in terms of what are the standards and we are adhering to, so to make this market faster, bigger for us.
So let me move on a little bit to, you know, kind of the elephant in the room that Martin and others hint at is the fact that additive manufacturing continues to be primarily viewed as something appropriate for prototypes and very low volume production. There are a couple notable exceptions in dental and some other places, but in many places, it's still not widely adopted. And, you know, so the question is, what do you believe is holding the industry back? And what is going to be necessary for additive manufacturing to move more into the mainstream so that it's not a, you know, 0.0004 or whatever it is percentage of the manufacturing? Maybe we could start with Harshil. You know, you have a view in talking to everyone and seeing the various technologies. what do you think needs to happen in order for additive manufacturing to become more mainstream?
I think at the first thought, I think it's honestly, I mean, and I'm obviously wholly biased here, it's the software, right? I mean, that's why I'm sort of refreshed by what Martin is saying. I think, you know, a lot of time and effort is being put on the machines and the science and the metallurgy side of things. But quite honestly, all the tools that everyone is using are ancient, right? And so you can only innovate at the rate at which your tool can iterate. And so I think that, you know, a renaissance needs to happen in the tool arena, whether it be us or anyone else, right? Like if we continue to use this STL file, that is not the future. That is honestly choking the industry. Any piece of software, whether it be NetFab, Materialize, or Cure, or whatever the heck else, if they keep pushing that STL narrative and story, I think it's honestly going to continue to choke the industry.
Yeah, no, Harshil, I say any software that was written before you were born should be thrown away.
Pretty much.
Meta, any thoughts about what we need to do as an industry to move it into more the mainstream?
Yeah, I mean, it's a very complex question.
Yeah.
It's a tough
By the
one.
way, this is the $64 billion question that's, you know, plagued the industry for 30 years.
Look, at the end of the day, you know, when we look at what we need to do, you know, as an industry, I think there's the customer side of it, there's us, and there's the market, and each of it has to come together in a way. So for us, we have to produce products that actually can compete with casting and other subtractive manufacturing at a cost that is acceptable. So you look at the machine and software and everything that comes with it, it isn't where it needs to be. So whether it's from a productivity cost, software, digital, it's still a young technology. You look at casting was done, I don't know, 4000 BC, and we're still doing it today. So there's a lot of, they got a lot of runway ahead of us to do. But you look at the customer aspect of it, and the customer and the additive with the customer hasn't used the additive to its fullest potential. A lot of it started with prototyping and parts for parts replacement. We know that, and that hasn't really, even your designers hasn't gotten to the level of designing it. So your engineers that are coming out of college probably just finally start getting into the additive. This entire ecosystem isn't where it needs to be, and the market has to support it as well in terms of funding technology developments from both us and the consumer. I think we all have to work on in our own space and help push the technology further by collaborating better. I think by working together to move the technology a little bit further, the day we start making parts that are competitive at a cost level, I think that's where you're going to unlock this billions and billions of dollars market. Until then, we're going to be just chipping one small chip at a time, and we'll get there. It's just how fast we want to innovate and how fast we want to invest, and how fast we want to really drive this cost per kilogram on and what the customer is judging us on.
Okay, Ryan, any thoughts?
Yeah, so I'm relatively new to this industry, so I get at least some benefit to make up for my lack of knowledge, and that I'm able to look at it with some fresh eyes and try and be objective without a lot of hard lessons that are won over decades of trying to make this industry successful. For me, the single biggest problem is that people aren't designing for additive. The opportunities that I've seen for additive at the end of the day come when additive needs to be favorably compared with traditional manufacturing for a particular part or portion of a bill of material. So the way I like to think of it is, you know, it's a new manufacturing process, just like every object in the room around us right now. It looks the way it looks, it functions the way it functions, it costs how much it costs as a result of the manufacturing processes we have available to us to make it. On top of that, we're starting to talk about workflow around making the AM process more powerful. And I think that's really good, because right now the hardware in a lot of ways outstrips the capabilities of the software. I can make every one of those widgets different. I can give it a personalized identification number to enable track and trace and all this great stuff, but the software isn't there to make that easy or straightforward for me. But then even beyond workflow and how we'd integrate that is our product development paradigm. Having come from other industries, I know that, you know, nobody's thinking about what can I do if I'm building this up a grain of sand at a time, right? If I have that level of control over my mechanical structure. And then also, what am I able to do if I don't have to get it perfectly right the first time because I'm spending tens or hundreds of thousands of dollars in tooling before I sell my first product ever? How can I change what a product is as far as my definitions go as an OEM or an innovator, so I can take advantage of not just the design space that I unlock with additive, but also the agility of being able to, you know, not put all my eggs in one basket, you know, and then sell that product, you know, in its first iteration, and have to be successful with that. So I think a lot of the parallels of what's happened in the, you know, in the software development space, additive enables those in the hardware space, but nobody's really taking advantage of it. And I do agree that once we're cost competitive or feature competitive with traditional manufacturing, that will just, I mean, be a waterfall of opportunity for this industry. But I think even before that, if we can get innovators to change their idea about how to bring a product to market, we'll have a much bigger window to win business and change minds beyond just the capabilities of our hardware. So that's how I think about it.
I was going to say, to jump in, I'm kind of curious across the board from a CapEx versus OpEx standpoint. I mean, I have this theory that I think the big fish or the big looming thing is really the OpEx here, because it costs a lot of money to train people to run these machines, right? Do other folks agree or disagree that the OpEx is a bigger fish that needs to be fried versus the CapEx of the machine itself? Because I mean, machine costs are going down, but I have this nagging feeling that it's all of the stuff that it takes to run them, which is the key kind of cost driver.
I would say we are like in the early industry PC days, yeah, the IBM PC, where you needed to be a certain kind of software nerd to know how to run MS-DOS and what an auto-exec bug is and configs is and how you are also doing these things. And this was it was limiting this technology to people who were really interested and not the broad majority. So definitely the software is providing the capability to make things easier, because it is capturing in the software in terms of setup, wizards, how to get the machine already to the right standard. And the other big thing is in terms of going to industrialize, yeah? So to bring our systems into the shop floor, is how are we integrating our machines into the traditional MES systems or distributed manufacturing. And today, when talking to customers and what I'm seeing is the printing cost itself is only 30 to 40% of the whole cost for this part. So there is a lot of post-processing. And the other thing, what the customer is costing is the quality inspection. Yeah? Is it really up to the right standard? And that you need for a metal system around, if you're starting new, it is still 6 to 12 months learning curve until you are really, really good in terms of understanding how to design for it. Another thing that we discussed it already several times in terms of that software can make here really the big difference in terms of capturing and understanding what is possible to produce on this machine and designing for this machine.
Got it. Okay. It might be a good time to start to move to some Q&A. So I see there's a bunch of conversation and questions and some provocative thoughts over in the chat window.
Yeah.
So maybe Sarah and Sean, you want to help direct the Q&A?
Yeah, let's go for it. Thank you, Carl, and everyone here. That was an excellent conversation. We've got a first question from Dylan Schickel, and it's a bit long, and I see that it's 2 parts. So I'm gonna go through the first part. So thinking about trends and looking out 5 years, does anyone see the supply chain transforming towards the possibility for digitally powered microfactory? Deployments of a small set of workflow-specific equipment making a customizable range of a narrow group of products at consumer-facing locations. These could be medical, dental, optical, foot inserts. Those are things that we've seen. But then also for customization of physical items like furniture or a home store. Think about what happened to photo printing in the late 90s and early 2000s. How could it apply to other useful items that could be more useful when customized? So I'm going to repeat the question. Does anyone see the supply chain transforming towards the possibility for digitally powered microfactory relating to customization? Oh, did I cut out?
No.
No, you're still there.
I think Carl may have cut out.
Oh, he did.
Go for it, Martin.
Definitely, that is distributed manufacturing, and I was just referring to that during. This is now the chance where people, and especially the market, is seeing as they are locked down in their facility and you cannot get out, to accept that you are going to a platform and you are asking for a design. You are asking for the manufacturing. You are asking for someone who is materializing or is developing for you the material. And it's up to us and also the rest of the manufacturing industry to hook up our systems to these platforms. And I think COVID will accelerate that.
Yeah, I saw a graphic online. It was about the uptake of technology, and it was talking about there was like COVID-19 hit and the line quickly curved up. So I do see that happening.
Yeah, and I think we have, and you mentioned it already, Carl, in terms of, for example, dental. Yeah, think about that you need still dental laboratories who are making sure that processes are followed and other things. But you have dentists and the local things who can send to the dental hubs the production, yeah, or even glasses. So we will see through mass applications, which are on one side individualized and on the other side highly customized, yeah, that we are getting to these distributed manufacturing platforms. And yeah, Ryan, I remember that it was in 2016, together with SAP, they started the first attempt together with United Parcel Service, yeah, to have these printing hubs and talking about distributed manufacturing. This was a little bit, it was 4 years ago. I think this is now coming more and more.
I think on the metal, we're still a little bit probably further than 5 years time scale that you're looking at, just because the metal is just, to do that, it just takes, the cycle is much longer than you would probably with the polymer. So that's my perspective. So yeah. I think we are going to eventually go in that direction, but the 5 years would be, in my opinion, would be too short.
Yeah, and I know, Carl, in our practice rounds for this panel, we talked about it's been decades for additive. And Harshil, you were mentioning what's up with this? CNC came on the scene way faster.
Yeah, I mean, one of the things that I think that was brought up already, I mean, many of the factors are in there. I thought one of the keys to unlocking it is actually having design software that's appropriate for designing for additive manufacturing. You know, if you look back historically, I mean, there was this nice coming together in which the underlying mathematics and the means of production and the things that people were making aligned. So if you look back at traditional kind of modeling technology, you have people using Bezier curves and B-splines and all kinds of nerves to make planes and cars on the appropriate kind of equipment. We've moved forward and we have new ways of making things, and yet we are still trying to do it with some of the same old software tools that are really inappropriate, you know. And so when you certainly look at, you know, some of the advanced things, when people are trying to make complex nozzles for, let's say, rockets, most of those modeling things take traditional software and bring it to its knees. It's not what it was meant to do. And so I think, you know, either software has to evolve, or new kinds of software need to be invented and brought to market that allow people, number one, to design these things. Number two is, you know, many people know I've been involved in kind of generative design for almost a decade now, which is, you know, the process by which we allow the computer to help us compute to make better designs. I think all of that is really important for making sure that we're going to take advantage of these new manufacturing techniques.
And if I could quickly build on that just a little bit, I think that what I also strongly believe is that, you know, the content and the data created through the design of the part is enough for to injection mold a part, because there's all of this iterative work to make that mold produce that part. But being able to realize a you know, future state of distributed manufacturing, you not only need to send the geometry of what you need made, you must also send the metadata that's appropriate to create that accurately the first time in an automated way. And no matter what process it's printed on, there's additional information that would need to be set up. Maybe it's just a material specification. Maybe it's a particular, you know, set of settings on that machine. So I think standards are so important, not just standards for the types of information that are shared in traditional manufacturing, but standards for the new types of information that will need to be shared to enable the distributed manufacturing future as well.
And that was actually oh, great for coming on, Harshil. The next part of the question was, how can Dyndrite help enable this?
Oh, well, I don't think I'll be that self-serving, but
I didn't plan this.
I do think that from like that distributed side, I think we're also going to see a lot of things that people didn't expect to be distributed, right? And I think one of the ones that's honestly surprised me has been in the automotive space, right? Whether we're talking about all these brand new car companies coming out, like for example, like Divergent 3D with that Zinger car, or whether it be all of the existing, you know, German automotives trying to figure out different ways to personalize the car, right? Like usually, you know, if you wanted to go buy a car with your initials in it and all that, it costs you about $150,000, and you could probably get it from Aston Martin. But now, you know, if we have a distributed way of manufacturing things, you know, if someone wants to customize some aspect of their car or personalize it, that's a very different proposition, right? And so I think from a micro factory perspective, I think there are a lot of obvious things, but I think there are going to be a lot of non-obvious things that come out. And the one that I'm kind of keenly watching is honestly in the automotive space. And so someone is going to have to help make those standards. Someone is going to have to help make it so that it's easy to send that data, as Ryan said, to all of these different vendors. You can't have one, you know, car reseller making it differently than another one, right? It needs to be all standardized and made easy to be, you know, to use and do. So I think we're kind of on the brink of that, and a couple industries are honestly going to surprise folks.
Awesome. We've got a question from Kenneth Wong at Digital Engineering Magazine. Hey, Carl, good to see you back in action. Do you think there's a need for a new kind of CAD, may not even be called CAD, a design software developed to produce geometry for additive manufacturing?
Yeah, absolutely. I think this really is a time in which we've seen some of the more exotic designs be done, and they're really not appropriate for, you know, to be designed with the old software. Sometimes it's possible, but you really need a new underlying mathematical foundation for doing most of this. And so we've seen a handful of companies pursuing fundamentally different, you know, modeling kernels, you know, mostly volumetric in nature. And I think that's one of the key things that has to be done. I think the idea of somehow modeling for additive in the old software is really very difficult. And, you know, you see this all the time when there's a new technology that comes online. People tend to make the old thing, you know, just like the new one. Like, it used to be funny when carbon fiber and other composites first came on, what I'd see is people using their old designs that were made for things, let's say like aluminum, and, you know, making them out of carbon fiber. And you'd look and you go, that, you know, that's just black aluminum. They hadn't really appreciated what are the special characteristics of the new material. In the same way, I think many people have underappreciated what's special, you know, about additive manufacturing. You know, people have hinted, you know, have talked about being able to customize it. So the mass customization aspect is really important. The fact that most additive machines are relatively indifferent, or at least highly tolerant of geometries that are not possible with other manufacturing processes. And so until people start designing that way, I think it's going to continue to be a smaller part of the market than we all would like it to be.
Yeah, and hopefully the software can help educate people to design better.
Yes, absolutely.
But also, I think, just to add to that, I mean, you know, I think there's two sides to that. So one of them, I fully agree, Carl, that unless you start designing for additive, you're not going to get the full potential.
Yep.
When you get into these type of computer-aided designs that are fully complex, it becomes very difficult for the engineer to understand the physics. It adds complexity in terms of, especially in certain industries that require certification and requires certain standards to be followed. I think we need to look at how do you, when you create that type of software, how is the industry is going to accept that as a design that's capable. I mean, obviously you have to go through a bunch of testings and stuff like that, but you know, you take that to an aviation or automotive, entry to bear, you know, there's so much barrier to entry into that. And changing the automotive or an aerospace or an aviation company to change that design practices to do that, it's a whole nother challenge that obviously we need to think about. So I think, you know, there's definitely, the digital space is extremely important.
Yeah, so Meta, I completely agree. So one of the things that I did, certainly when we were at Autodesk, we saw the exact same challenges. So like when people mention aerospace, you know, immediately they jump to like Boeing and Airbus, you know, commercial. That's probably the most difficult space to enter. But if you look at space, people are more than willing, you know, and you look at a number of the rocket companies out there, they're way more innovative and way more tolerant. And failure is part of their exploration. The same thing, I've seen the same thing with military aircraft, you know, and things like drones. So I think you have to be careful. I think when you get to the high performance automotive, so rather than thinking about the mainstream manufacturers that it could produce millions, how do we find these kind of toeholds to start showing what the potential is? I think people get kind of suckered by the commercial opportunity presented when a Volkswagen or a Toyota says, yes, I might make this part. And, you know, it could be 10 years in the making.
Exactly.
Whereas you have to find parts of the industry where the cycle time is just faster and their demands are just higher, whether that's for lightweight. I also think there are some places where, you know, we've probably tilted at windmills a little bit, and places where some of the like multi-physics, where it is not only structural, but it's things like thermal or optical that matter as well. And that combination is something that's uniquely done. So I think we need to find more places where it can provide something that traditional manufacturing can't do, rather than just go, you know, head first because we think it's a gigantic commercial opportunity.
Well, I'll take it even to another level. Is if we go that far, do we need an engineer?
Well, look, I spent 10 years, like I said, you know, advocating for generative design. And, you know, and many of the designs you've seen are truly computer aided, you know, if not computer generated. And I think that's a huge part of the future. And particularly as the generative software starts beginning to understand the manufacturing process. If it's ignorant of the manufacturing process, you will have the exact same problem, maybe worse. You know, if a human is ignorant of the manufacturing process, the designs aren't great. If the software isn't, it's going to be dogmatically wrong about what it produces. And so I think it needs a real understanding. I think I poked Harshil there. Go ahead, Harshil.
I was going to say that I think the role of the engineer is going to change, right?
Yeah.
Right. Like in the talk that I gave yesterday, right? One of the key differences that I pointed out between an engineer from the last decade and this decade is that most of them know how to program something, right?
Yeah.
And so the interesting thing here is I think it's going to shift less and less from designing this specific model using this type of specific CAD software, right? And going to more of a, how do I functionally describe what I'm trying to go do, and how do I effectively program that into the software?
Exactly. If you look at, for example, chip design these days, people don't lay out individual lines anymore. Back in the day when you had 5 connections, you used to lay it out. Now when there are millions, the software takes care of this, and it's one of the tasks that software does really well. Are these repetitive tasks where it needs to explore a complex space. So we should use the software to do the things it does well. Describing the problem and assessing the trade-offs between various designs, that's a more human activity.
I agree totally to that, but I think there's one important thing is visualization, that the software helps the engineers or the persons in front of the computer to understand what it has calculated and what it is showing. So like you remember, and I learned that from Andrew, he was saying CAE, everything was Andrew Anagnos. Everything Martin is already invented. It is all about who can in the best way visualize it. And I think the big breakthrough was once you had the FEA and you still need to understand what is all these special terms and other things. And when we suddenly could visualize, this is the safety factor higher than 5 or other things, that is where the broad audience better understand the result of what was computed. Yeah? And you were saying one other big important thing. Yes, generative design and topology optimization need to be combined with the material properties in certain areas. So voxel based in terms of saying in this or that area, then you can again use huge advantages, especially in metal design, to save weight, cost, production time, and other things, and to combine it with the iterations. Yeah?
We also, those are some good thoughts. We had a good question from Dwayne. He says, can we consider changing the language we use to talk about modeling? Geometric modeling is no longer sufficient. Wouldn't we be able to make better progress if we talked about and thought about other properties with an equal footing to geometry? So what do you guys think about language?
Well, I think the essence of his question is absolutely right. As a matter of fact, one of the big complaints against many of the traditional modeling systems today is that they require a degree of specificity around the geometry way too early in the process. I mean, I just shake my head when I watch people early on in the design process, drawing curves and drawing fillets and, all kinds of stuff before they even know whether or not they solve the engineering problem. But, it's kind of the requirement of the way that kind of design is done. And certainly you would like to know your mechanism works, or, the thermal properties, the thermal problems are solved before you get down to a very specific level. And that's the advantage of moving to, an outcome-driven design, as opposed to kind of bottoms up, starting by, sketching and extruding.
Mm-hmm.
But also, right now you can do much faster turnaround. So you can print it and test it in quickly than you did before, where you spent, 8-9 months, making your designing drawings and getting the part and testing, then it fails in another year, gone by. So I think I think it's going to definitely change the entire landscape with digital, plus also the 3D printing allows you to do things much faster, quicker, and test it much, much faster.
Some follow-up on that from Hayden. How can we get away from the concept that some people have, some people believe AM produces perfect parts in a lot of ways, it creates a situation where people are disappointed when they realize the limitations of AM, and it turns them off to the idea that AM, when it could be viable alternative to traditional manufacturing. What kind of education is needed, and how can we put that in the hands of those people?
There is no such a thing as perfect in the world, any world that you, whether it's additive or subtractive or what have you. Look, this is actually a good point where I remember when we had a lot of hype around additive, and a lot of people got into it without understanding it, fully understanding it, until they start really getting into it and they found limitations that the current technology has. Again, I said earlier that the technology is still young, relatively speaking, compared to the other technologies. We have a long way to go in terms of, the capabilities that we have today on the machines are not fully utilized. We talk about a lot of software. Look at how much software capability we are using in the machines. It was very, very limited. How much software, capabilities we do in post processing.
Oh, here, yeah. Okay. Yeah.
So again, I think there's a long way to go to get this technology mature enough, and we need to educate about the capabilities of each modality, whether it's binder jetting, whether it's laser, or whether it's electron beams. Every technology has limitation capabilities, and the user has to understand, or the designers have to understand the capabilities of each of these technologies.
Yeah, and if I could just jump in here real quick, I think in some ways we're kind of like adding some conflict to the question, where we're saying, okay, what's going to help push it forward? What's going to help make additive a lot more mainstream? But yet by the same token, now we're trying to put ourselves around this idea that, well, we need a special CAD program. We need a special file format. We need a special this. We need a special that. And, here's the thing. If I'm an engineer coming out of college right now, I can sit down at my CAD system, draw my part, dimension it, put it on a drawing, and I have something called the engineering control block. We don't have an engineering control block in additive. Like I have a spot where I can say, these are my manufacturing tolerances. This is the material I want. And I can send that drawing to 10 million machine shops all around the world, and everybody's going to know exactly what it is that I'm after. And I feel like in additive, we're surrounding ourselves with so many of these special requirements and special needs. Is that actually going to help us move faster, or is it going to make it take that much longer?
Yeah, good points.
I was going to say, I was going to lean in more into what Meta was saying with, printing and simulation. I'm as someone who had a degree in computational fluid mechanics, I think I would rather print something and just test it than actually go through the effort of even setting up that simulation, right? I think that's a realization that someone, and that the world is so enamored with this whole simulation-driven design concept. I think there's an opportunity with additive manufacturing to have a manufacturing design-driven concept where it's actually probably much cheaper to just print 1,000 rocket nozzles or 1,000 brackets, just go destructively test them, than in the time that it would take for you to simulate it. In fact, I would go further to say, at some point you even have to validate it anyway, right? So why not just start from the finish line as opposed to going through that whole process, right? So I think the perspective that people are taking, like even what Dan was talking about with, I don't think you necessarily need new software per se, right? If you could just print in mass quantity those things and then just test them, I think that's going to honestly just change the way the engineers themselves even work, right? So I don't think we need perfection. I think what we need to hand on is speed. How fast can you iterate much, much quicker?
Mm-hmm. We've got a question about business from Pete Basiliere. Businesses will come out of the pandemic at different rates, if at all. They will focus on ramping up their supply chains and manufacturing processes with various degrees of success. What actions will you, as an industry supplier, take to facilitate the increased use of additive manufacturing when many of your customers and prospects are just fighting to survive, never mind striving to grow after the pandemic? So that kind of piggybacks on what Todd was speaking about this morning.
It's similar to what Carl asked as one of the first questions, where what are we each doing to make sure that we're taking appropriate actions to come out of the pandemic stronger. So, you know, we have different customers across different verticals, and Pete's exactly right. Each of those are going to have their different timelines. They're being disrupted different amounts, and they're going to have different ways that they pull out of that recovery. So ensuring that we have that close contact with our customers gives us the best information to help support that. And then what are we doing to facilitate that increased use of AM? I mean, that's gets back in my point to driving for more cooperation and integration with the way that they do things. I don't think any one of our companies is going to be able to drive a recovery or increased adoption of AM by ourselves. And to Martin's point, we have to come together, recognize that this is an important moment. Maybe it's not a true watershed moment where things will never be the same, but there is an opportunity here. And I think we can capitalize on that if we do work together in our storytelling and in our recognition that there will be differences of importance in the way companies see their supply chain and their willingness to adopt new technologies to support that.
Thank you, Ryan. Did anyone else have any other thoughts before I move on to the next question?
I think there's, like I was saying at the beginning, there are good projects already running where the customers are still keeping contact with all of us, and they are eager to go forward, and they are using also their time. Yes, I think we will see certain dip in terms of the growth, because like I was saying, yeah, people will save certain money, but I think this will be only for a certain amount of time, and then we will grow even further, because we are at a breakthrough point in terms of showing where in certain industries is it, and you are right, in space industry, it is also in automotive industries, in industrial machinery, yeah, with turbines where higher efficiency, where they discovered the advantages of additive manufacturing and they want to continue.
Thank you. All right. I'm going to take a question from Srikanth Nottingham. Critical components metal in aviation and aerospace is going to need inspection to address risk. Inspection of topology, optimized or otherwise, that are complex in shape poses significant challenge. If this aspect is not properly addressed by the industry, it will be difficult. As history has shown, failure is not a matter of infant mortality of a 3D printed part in aerospace can cause ripples in the industry. How will we address this? So how are we managing quality control, inspection of topology, shapes?
I mean, there's a lot of technology currently is being used and is being developed by all of the OEMs here to drive the quality on the parts either as you print it or post-processing. I think you're going to see a lot more as software becomes smarter and technology becomes more as technology becomes more mature. You're going to see, I think, much more smarter machines that actually have the capabilities to do on-the-fly quality verifications and quality checks. Currently, you see a lot of OEMs providing, pool monitoring and other things in layer by layers. You even see even some industries, you see post-processing doing a scanning and other things. I think that we're going to get away from that as we go forward, and as the technology becomes mature and the applications becomes more rapidly ubiquitous. So I think you're going to, to me, this is less of a risk going forward than anything else I see out there.
Yeah. When you were looking at last year's Form Next in November, where now 4 halls were filled, and how many around quality assurance and inspections, big players, yeah, which are already known in the area of quality inspections were there and were showing what they want to do, but also a lot of new startups. So there will come a lot in terms of helping to do the quality inspection, yeah, right during the printing, but also in terms of post-processing. That will help, and that is an important thing, that we are getting a community which is helping us around making the total cost of ownership, yeah, not only the printing and the powder consumption, but the post-processing and the quality insurance more cost effective. And we are seeing that these companies are coming and joining the ecosystem.
I think additive has an advantage in this space than other technologies, because in additive you have capabilities to do it upfront, and you can even tailor your designs to be even tolerant to certain flaws in the manufacturing processes. So I think this is an opportunity for additive versus a risk.
Yeah.
Okay, I know that Carl has to is running out of time. So I just have one last question. It'll be a softball for everyone. By the way, thanks everyone for the great questions and answers that you've given. So I just have a softball question. One of the things we've heard here in this talk is about the need for increased tools, new technologies, and so forth. One of the new technologies that hasn't been discussed here, actually an old technology, but is the GPU and how that could be applied to some of these problems. Now, this is, of course, again, a softball question for Dyndrite, but I want to see across the panel what people think about the impact the GPU can have in this space.
Big one. As we have to calculate a lot of things, alone if I'm thinking about the task generating, GPUs can help you to get 10 to 100 times faster in terms of doing huge job calculation. And that's definitely something we are not only trying out, but also having. So it is an important accelerator, yes.
Goes back
Yeah, I
to
agree.
this. Oh, go ahead, Dan.
Okay. Hey, thank you. I was going to say, yeah, I agree. I mean, we've been using that for a long time, and you know, with binder jetting, we just need to get to a bitmap, right? Like we don't have to have tool paths, we don't have to have power rate. You know, like our thing goes back and forth and spits out glue. So, you know, we've been leveraging the power of the graphics card for generating bitmaps for a long time because it's frankly the best way to do it. And you know. But I'll put a question back to you that you can wrap up with after everybody else goes, Harshil. But what do you think the implication of some of these new quantum computing technologies are going to do for this kind of an industry?
So I think this, for my portion of this answer, it comes back to designing for additive. I think one of the most exciting realizations that I had as I learned about this industry was that arbitrary complexity can be free. Right? Complexity always costs money in other manufacturing technologies. So once the world really appreciates the fact that complexity can be free or close to free in this space, the demands for the complexity geometry are going to explode. And when I look at other technologies that aren't GPU enabled, I worry about their ability to scale for the future of this industry. And so I do think it's a very important component to be able to keep up with the demand.
Great.
I was going to answer Dan's question. I think it's why I think modern software needs to be built to use all types of compute technologies, right? So I mean, everyone on this panel is familiar with all the different types of exotic ways to go print something, right? Like I feel like every other day a new acronym is created for how to go heat something up, glue it together, and build it up, right? I think an interesting similar thing is happening in chip design land, right? Because with the advent of all this AI stuff, VR stuff, people are starting to realize that they don't want one type of chip to do everything, right? They want to have all kinds of chips, whether it be for inferencing for cars or whether it be, you know, doing special ray tracing, you know, what NVIDIA did with the RTX technology, you know, or what you mentioned, right, with the quantum computing side of things, right? So I think modern software kind of going forward needs to be kind of compute agnostic and needs to also acknowledge that all kinds of new exotic chips are going to be made that help different types of things, right? Like, and quite frankly, the one that I'm most interested in is all of the RTX stuff that NVIDIA has been doing recently, because that specifically, you know, helps with BVH traversal, which is paramount for everyone on this panel, right? And that was originally built for an entirely different purpose, and I think could be used for example, toolpath generation. So I think the key is going to be recognizing that we're not just CPU or GPU or whatever the next thing is. It's that industry in and of itself is also evolving, and people need to be cognizant of it.
Awesome. I don't know if anyone gives any last, well, actually, Middag, we didn't have a response for you. I don't know if you have a different or
No, I agree with all of the comments. I think, look, this is, again, I said it earlier, I think we're just at the beginning here. And we got a long way to go in terms of both maturing the technology and getting the technology. 5 years from now, or 6 or 10 years, you're going to look back and you look at the current architecture that we're putting out there in the industry, and you're looking at everything we put it together. You look at it, you're like, wow, that looks really, really old stuff. It's going to look very, very outdated. So I think the technologies, we got to keep up with this technology, and definitely the entire system, whether it's software, hardware, everything has to come together. And I think you're going to see a lot more. I like about this industry is actually you have a lot of innovation in it, and you got each of us here driving the other guys to do better and better. So this is a healthy competition that's driving us to innovate, which is good for the industry and good for everyone. And we just have to do it in the smart way so we can help each other move forward. But whether having computing is going to be big. It's part of software, part of, as we're talking about these different designs, adding complexity into the machines, it is going to need some much more computing powers. We're going to see much more software that's getting integrated, much more sensing integrated, much more. So I think I think my vision, it's going to be 5 years or 10 years from now, the machines will be extremely automated for a digital ecosystem that's self-sustained, maybe even with some type of artificial intelligence, if we can go that far. Machines are going to be a lot smarter. They can do much more capabilities. So the sky is the limit, and I think very excited to be in this industry.
Awesome. Harshil, I think you have one last, maybe a wrap up, and you have something to also mention. I'll share my screen.
Yeah, so I wanted to thank everyone for not only joining this panel. I know everyone's busy, even while at home, but I wanted to personally thank Martin, Meta, Dan, and Ryan, and Carl for helping join this. So thank you all. Thank you for all the folks who attended this conference, and I hope it was useful to all of you, and you'll use this to continue building connections, and as Todd said earlier today, not fall into some kind of a depressive state, but realize that this is an opportunity, and all kinds of things are kind of happening in the background. Towards the end of the conference, Sean's sharing a screen right now to show that a number of vendor sessions are going to be opening up. So these are essentially the presenters who presented today. I know there are a lot of questions that were unanswered, so if you do have those questions, please go to this link. I believe it was just sent via the chat to everyone. Folks should be there to answer your questions. All right, and then what I wanted to announce at kind of the end of this was kind of what we are trying to do from a, helping the industry standpoint. We work with a ton of startups. We give a lot of free software to a ton of startups. And it's clear that at least from the COVID standpoint, all the startups are hurting, right? Most of the startups do not have multinational arms where they can continue to go do business. Usually the CEO or the COO or the other founder is traveling. And so what I wanted to do to kind of end this event was to sort of announce an initiative and the next event that we're hoping to host. We're trying to get everyone in the community who is needing help and who is past a certain point in their business career to host essentially an investor day to help elevate the entire industry and help it kind of continue moving forward. Right? I think there are a lot of interesting ideas out there, whether it be software, hardware, or otherwise. And so the goal was to see if we could do our part at Dyndrite to help folks be connected, at least with Silicon Valley and the rest of the investment community. So again, if you are interested in that, or if you fall into that Seed Plus startup category, please check this out. We're still formulating it, but the goal was to figure out a way to help the community at large, not only by hopefully giving them nice and free software, but also by connecting them with the various folks who could help them financially. So thank you all for attending this conference. Thank you all again to our panelists for having an awesome discussion. And yeah.
Good discussion. Thank you.
Yeah, thank you.
Thank you.
Yes, thanks, everyone. Thank you, Ryan, Martin, Dan, Rada, Harshil, and we'll see you in the vendor lounges. Thanks so much.
All right. Thank you. Bye-bye.
Bye-bye. Take care.